Okay, here we are in 1.6, subtraction of real numbers, which means that we're going to be focusing on subtracting positives and negatives, but also not ignoring fractions and decimals. So real numbers includes all of that. Let's recall how we dealt with adding positive and negative numbers, and that was from the previous section in 1.5. And had a math teacher once tell me that when you hear an instructor say recall, what they're really saying is don't remember this, learn it quick, because this is what we're basing today's lesson on. If you have same signs, for example, a positive plus a positive, or a negative plus a negative, this is what we reviewed from this is a review from last section. Same signs. That reminds you of the word sum, which means to add the numbers. And we're going to keep the bigger sign. Well, with same numbers, you just keep or with same signs to begin with, you just keep that sign. The reason why we phrase it as keep the bigger sign is that allows us to keep that same pattern of rule for both same and different. You don't have to wonder, when do I keep the bigger sign? You just always keep the bigger sign. The other two situations you'd come across besides positive, positive, negative, negative would be if the signs were different. So positive plus a negative, negative plus a positive, and the word different, we want it to trigger in your memory the word difference, which means to subtract the numbers. And again, we will keep the bigger sign. And the reason why I review this in detail in the notes here is because to deal with subtraction, and we've mentioned this in a couple videos throughout the term so far, I've also mentioned it in class, subtraction is really just changing, subtraction is really just adding the opposite, or adding the negative. We are changing the minus to add the negative. So it becomes a plus the opposite. So adding the negative, or you can think of it as add the opposite. Or you could think of in terms of change the sign of the second number. There's all kinds of different ways to think about how to do the subtraction, but we're all doing the same thing. Now let me give you a quick example, and then a quick kind of reasoning why, and then we'll look at the examples down at the bottom of this page. So in this first demonstration here, I just want you to look at a comparison. 15 minus 2, compare it to or versus 2 minus 15. Knowing what we know about, say, like bank accounts and withdrawals and just subtraction in general, I would hope that you're at a point where you could agree that 15 minus 2 is positive 13, whereas 2 minus 15 is negative 13. Okay, because if you have 2 in your bank account, you write a check for 15, you're going to owe 13. You have 15 in there, you write a check for 2, you're going to be fine, you're going to be left with a balance of 13. Now let's look at what we know to be true in light of this pattern that we're saying. We're saying you can take every addition and make it into, or I'm sorry, you can take every subtraction and make it into an addition of the opposite. And let's see what happens here. Okay. So if I were to rewrite this as adding the negative, so it would be 15 plus a negative 2. Okay. Then we would see that the signs were different, because we've got a positive 15, so we've got different signs. So we would subtract the 15 minus 2 is 13, and we would keep the bigger sign, the positive here. So we'd see that this answer would be a positive 13, based on following our rules for adding positive and negative numbers. Okay, that matches our that rule lines up with what we just understand about moving left or right on the number line. Okay. Let's look at the 2 minus 15 in that same light here. Let's change that subtraction to adding the negative. Okay, just a different way of looking at or thinking about subtraction. And then you would have the positive 2 plus a negative 15. Again, the signs are different. I guess I should have finished writing that. Different signs, so we subtract, keep the bigger number. Again, you subtract 15 and 2, you get 13, and you keep that bigger sign there. Keep the bigger sign. I keep saying numbers, sorry. Keep the bigger sign. You would end up with a negative 13, which is what we expected, just using kind of common sense there. So, once again, 15 minus 2, 2 minus 15, order matters. Let's highlight that part. That's an important thing to always keep in mind. When you're dealing with subtraction, order matters. Okay? When you convert subtraction to adding the opposite, adding the negative of what you see. So this was minus a positive 2. We change it to plus a negative 2. This was minus a positive 15. We change it to plus a negative 15. When you do that, you eliminate having to worry about order, because addition can commute. It can switch back and forth. Okay, so we're going to look at some examples of that. I'll say it again many times this term. If you are already good at adding and subtracting positive and negative numbers, then don't try to change the way you think. Don't overhaul everything. If you're good at positive and negative numbers and you're watching what we do, how I present these problems, and you're going, yeah, I get that. That fits in with how I think about things, then great. But if you're looking at it and it's adding confusion to what you already know how to do, then stick with what you know how to do. Because if your method is working for you, it's getting you consistently right answers, you're good. The reason why I present things the way I do is because we're going to head into algebra using these skills, and what works for numbers works with algebra. So we want to make sure we're establishing a pattern that allows us to replace these numbers with unknowns, variables, and still be able to accomplish the math involved. Okay, so on page 62 in the book, there's a definition of subtraction, and write it out very similarly here. A minus B equals A plus the negative there. Okay, we'll see you at the bottom of the page to do some examples together.